Now that we have run our program and saw this output, which is printing the hello world on the screen, we want to have a look at the different files that we have created. Again, this was assembly. We first created an object file using the assembler, and then using the linker, we created the executable, and by running the executable, we saw the result, which was printing the hello world on the screen. Now we want to analyze these different files which we acquired the related knowledge in the previous module. So in here, I just clear the screen and type x6d and then the hello world program and pass it to the more and hit enter. So this is our file. If I just press space a couple of times, we get to the end of it, which is 3F0 at the pointing at this address in here. So I open another terminal and go to the Python interpreter, and we would have we want to get the size. So I say 3F0 with the base of 16. I hit enter and it would be 1008. But this 3F0 is pointing to begin address in here, so we should add it with the last 16 bytes in the same row. So in here I say 1008 plus 16 bytes at the last row and hit enter, we get to 1040. Of course, if I calculate the hexadecimal of 1024, we would know that the address of this last byte would be 0x400 in hex. Now I open another terminal, and in here I say ls-la and then the hello world to see the exact size, and if you notice it says 1024, which means that we calculated it right. So we have everything in the L file in here. So we just want to look at the different headers. Again, you have the knowledge to just look at these bytes and understand what each of them say with just looking at the manual page of the ELF. But now that we know how they work, I just want to use the readelf command to see the different headers. readelf-h and then the hello world, and we hit enter. So readelf, not radelf. No, readelf and hit enter. This is the first header. If you look, it says the first header is 64 bytes, which we get to the starting point of the program header. So like before, these are always constant, the first 4 rows for the ELF header. Then we get to the program header, which its size would change. So other than the ELF header, everything would change based on the file itself. So in here, the program header would be 56 bytes. We would have 2 segments, and in the program header, the structure which explains about each segment would be 56 bytes. Or in another word, we have 2 entries in our program header table, each of which is 56 bytes. So in here, if I just say 56 times 2, we get to 112 bytes. And then it tells us that the beginning or a starting point of the section header is 640, is at the address of 640. Also, it says that the section header has 6 entries, which means that we have 6 sections, and each entry in the section header table explaining about each of the sections would be 64 bytes. So you say 64 times 6, we get to 384 bytes, which means that the section header is of this length. So if I say 64 plus 112, which is the size of the program header, plus 384, the size of the section header, we get 560. Now if I say 124 minus 560 and hit enter, we get to 464, which is the size of the data in our file. So as you see, the headers added to the file explaining about the data is bigger than the data itself. We could just analyze it in another different format. For example, the starting point of the section header is at the 640, and the first 64 bytes plus 112 would be the header, the ELF header, and the program header. So if we say 640 in here, 640, which is the starting point of the section header, we know that section header comes after the ELF header, the program header, and the data itself. So if I subtract the ELF header and the program header from the starting point of the section header, we get this to the size of the file, 640 minus 176, and hit enter, we get to the 464 again, which is the size of the data in our file. Now we want to see our data in different formats. One of them, for example, you could see different segments in our file. We could just say readelf-l and then just say the hello word and hit enter. We see the different segments in here, or as I usually prefer is to look at it in the sections, or at least when we are analyzing it, so that we have a better understanding or a better layout. So in here I say readelf-s and then hello world, and if you look, it gives us 5 different sections in here. In the, again, let me just say readelf-l hello world to have the segments in here also. So in here, if you look, we have these 5 different segments, the text and the data, and some other sections which has been added to the file. For example, so these are all part of the data. All the 464 bytes, these are all part of the 464 bytes of our data. The last one would be the section names. It would include all the section names. This would include all the instructions. This will include all the data and so on. So in here, if we want to go, if you look, the text is at the beginning of the file. Also, we know that at the position of 176 would be the starting point of our address, of our data, right? So I want to go to this exact address to see our real data. So in here, I say this, provide the -s 176 and hit enter, and this would be the beginning of our text section, as you see in here, and the size of our text section would be 27 in the hexadecimal, which if we just say 27 and hit enter, we get to 39, which means that we have 39 bytes in here as part of the text section, or we have only 39 bytes of instructions. This would be 16 bytes, 32 bytes, 34, 36, 38, and 39. So all of these 3 rows in here would be our text section. After that, we would get to the data, which our data is just 12 bytes. And if we look, it would start at here. So we have 68, 65, 60, 60. If you look, it has been the ASCII has been dumped. It is hello world. We could just, as we explained in the previous lecture, you could just copy this, go to the Python interpreter, import the bin ASCII. Again, like always, you could use a calculator. So I say bin ASCII.unhexelify and copy it in here, paste it in here. Also, so it would be 12 bytes, right? We saw in here that it is 12 bytes, the data section. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 bytes of the data section. So I paste the rest in here and remove them. So it was 640R. It was C, I think. This was C in here. So we just remove these spaces, which I should have removed using a strip. So I hit enter, and we have hello world in here. I think I made some mistake in here. So again, let me just make sure. Sorry for the mistake. So copy bin ASCII, paste, and this would be the last 4 bytes and we paste it in here, hit enter, and we have hello world and the null character at the end, or the new line at the end, actually not the null character. So these are our 12 bytes in here, which you see as part of our data section. And after that we get to the other sections. Also, if we want to just look at the last section, which is shstr tab, and includes the section names, if I just hit a space, you see that in here we have all the names of all the data as part of the last section of the data, and this would be the beginning of the section header, which we know the first 4 rows or the first 64 bytes are null. In here you see the first entry in the section header table. If we just convert the 280 to the decimal, we would definitely get 640, which is beginning of the section header. So let us just make sure if this is the section header starting point. So I just say 280 and hit enter, and we get 640, which means that this is the beginning of the section header table. And from here to to the end of the file would be each 40 bytes would be explaining about one of the section using which the read elf has retrieved all this data about different sections.